Hello class, we're about to start section 5.6, natural logarithms. Introducing a new irrational number. Normally special numbers are identified in math because they are useful. One such number that you already know about is pi. What is pi and why is it useful? Pi we typically write as an approximation, but pi actually goes on forever. So we can write the first four digits after the decimal and these dots here or periods to let you know it goes on forever. This goes on forever. With no pattern. And it's called irrational. Remember, irrational numbers goes on. There are decimals that go on forever and they do not terminate or they do not repeat. Now, one thing pi is very useful for is finding the circumference of a circle. So if you took a circle, a circle, well, we could do this. We could go across here and this could be the diameter, which is d. Now we know a circle's circumference is pi times the diameter. So this is where pi is useful. Now, another special number in math is the number represented by the symbol E. What is E? E is approximately 2.71828 and it goes on forever. Now, why is E useful? It's useful for bank accounts, typically in calculating interest. And also business, science, and statistics. And that's just to name a few. Now, it says here, it was first studied by the Swiss mathematician Leonhard Euler in the 1720s. Euler was also the first to use the letter E for it in 1727. The fact that it is the first letter of his surname is coincidental. As a result, sometimes E is called the Euler number. Natural exponential function, f of x is equal to e to the x. The logarithm function is natural log, even though it says ln, that means natural log of x. And remember, this is an L, not a 1. Note, these functions are a logarithmic function and an exponential function with the same base. Therefore, they must be inverses of each other. Now, one other thing you need to notice, on your calculator, they're on the same button. If you look at the button on your calculator, you will see the LN button, and then if you press second function and then press the button, you will get the E. Now, example 1, it says simplify the following. We have the natural log E. Now, natural log E is the same thing as saying log base E of E. Now that equals 1. Now E to the natural log of X, just like we did with our regular logs, they had the same base, they simplify out and leave what's left, which is the X. Now we have the natural log E to the 5th. So this base is assumed to be E for the natural log. And these will simplify out, and your answer is 5. Now we come here to D. We have the natural log of the square root of 3. So first of all, let's rewrite this in its exponential form. Remember, when you don't see an index, it's assumed to be 2. So this is the same thing as saying the natural log of e to the 3/2 power. Now this natural log, remember, it's assumed that its base is e. These simplify out and it equals 3/2. Now we go here to e. We had a natural log of 1 over e to the 3rd power. Okay, now we'll rewrite this. This is the same as the natural log of e to the -3 power. These will simplify out and your answer would be -3. Now we have e to the natural log x to the 1/3 power. This e and the natural log would simplify out and you'll be left with x to the 1/3 power. Okay, class, I took the liberty and added in a few more examples here. We have g. Now what you may have to do is pause this and copy all of these down, and then you could go back and listen to my explanation. So I would suggest you pause it now and copy this down. Okay, now what we need to do is this here. We have a natural log of the 5th root of e to the 3rd power. We solve it the same way as we did d. We will make that to the 3/5 power, the e. This natural log and e will simplify out and leave you 3/5. Now we go here to h. The only difference between h, d, and g is that it's 1 over this radical. So we know that our exponent, let me put this in a parenthesis, our exponent would actually be negative. It still would be 3/4, but since it's in the denominator, we will make the exponent negative. And they would simplify out the natural log and the e and leave us a -3/4. Now we go to I, the natural log of -4. Now remember, just like in log, our argument cannot be negative, so this is undefined. So now we come to j, the natural log of 0. Now remember, we cannot have 0 or a negative number as our argument, so it's undefined as well. Because remember, the base is e. Can you think of e to what power that would give us 0? There's no such thing. Or e to what power would give us -4? No such thing. So here we come to k. Now with k, we had a natural log of 1. Now remember, it's assumed to be an e as a base. We know e to the 0 power will give us 1. So our answer here is 0. Okay, now we come to the next page here. It says example 2. Collect the logarithms in each expression. Write your results as a single logarithm with a coefficient of 1. So now we're going to write this as a natural log. Now the rules for natural logs and logs are the same. So just like with the logarithm, we would take this 1/2 and put it as an exponent of n. We would do that here. So it'll be natural log n to the 1/2 power. This 3 would also go with the m, and it'll be natural log m to the 3rd power. Now, we can combine these because this will be multiplication. It'll be the natural log of, we could change, well, this would be n to the 1/2 power times m to the 3rd power. Now, we could make this into a radical, so this could be your answer, or we could write natural log and have the square root of n times m to the 3rd power. Either one of these will work. Okay, now we come to b. We do the same thing. We add natural log of x squared plus natural log of y to the 4th minus natural log x to the 3rd. Now we will have the natural log, and we will have, okay, now there's one correction I want to make. There was a little error here. This plus here is supposed to be a minus. And we would make this plus here a minus as well. So change that in your course pack. There should be a minus instead of a plus. So now we have natural log. It'll be x squared in our numerator. And our denominator, we will have y to the 4th power times x to the 3rd power. Now we can simplify that, so that'll be the natural log of 1 over y to the 4th times x, or y to the 4th x. And that is our final answer. Okay, now we can go to example 3. It says solve. Give 3 decimal places where necessary. So you would have to use your calculator here. So we would subtract 5 on both sides. And we have 8e to the 3x minus 1 is equal to 28. Now we divide each side by 8. And we will have e to the 3x minus 1 is equal to, now 28 divided by 8 is 3.5. Now we will put this 3x minus 1 in a parenthesis. Now we're going to take the natural log of both sides, just like we would do with a log. The natural log and e would simplify out, and you will have 3x minus 1 on one side is equal to the natural log of 3.5 on the other. Now, we will add 1 to both sides. Now, one other thing, we need to put this 3.5 in parentheses. But again, we will add 1 on both sides. And we have 3x is equal to the log natural, or natural log of 3.5, and then plus 1. Now we would divide each side by 3. And we will have x, and we're going to round this, so x is approximately 0.751. We're supposed to round to 3 decimal places. Now we go here to b. Now b, we have 3e to the x minus 12 is equal to e to the x plus 12. So what we need to do is get all of the e's on one side and all the numbers on the other. So first of all, let me separate this here. Okay, so what I would do is I would subtract e to the x on both sides. And then I would add 12 on both sides. So 3e to the x minus e to the x is 2e to the x. And that equals to 44 plus 12 is 56. So we divide each side by 2. And e to the x is equal to 28. Now we need to take the natural log of each side. And we would be left with x is equal to the natural log of 28. Now the natural log of 28, as an approximation, is 3.332. Now we scroll down. Now it still should be on the same sheet of paper as yours, but I had to make myself some room to get those problems in. So now we come here to C. We have 2 natural log 5x minus 3 equals 1. So first we will add 3 on both sides. So we have 2 natural log of 5x is equal to 4. We divide each side by 2. We have the natural log of 5x is equal to 2. Now, again, what we need to do, we need to get x by itself here. So what we could do is this here. We have log natural, or natural log of base e, 5x is equal to 2. Remember, this base is e, so we would write this as e to the second power is equal to 5x. Now we would divide each side by 5. And we will have x is approximately 1.478. Now we come here to D. Now again, first thing we need to do is set this up, make it as close to a singular logarithm as possible. So we have natural log of x to the third to the second minus the natural log of 8x to the fifth equals 1. Now this will give us the natural log of x to the sixth minus the natural log of 8x to the fifth equals 1. Now, you notice this is subtraction, so we have the natural log of x to the 6 over 8x